Thank you, Kate. I hope you can hear me okay. I'm speaking directly into the mic and going to be kind of maintaining a steady pace so that you can follow along because I have some data for you to look at. And so for that, I want to kind of pace myself so that you get a better idea for kind of transitioning from this kind of 5,000-foot level of recognizing what was happening, identifying what was happening at the federal level, then how that was administered into specific neighborhood segregation policies that had specifically to do with race and income and immigrant communities, African Black Americans living in redline neighborhoods. And so what we're looking at here is thinking about undoing landscape legacies. We know this happened from the 1930s all the way up until the 1960s, and the Fair Housing Act kept redlining from happening and no longer allowed it. Nevertheless, it still persisted in a variety of different ways. However, what we're inheriting from that is this almost lock-in of landscape where we're trying to unpack now why some neighborhoods have more canopy and other neighborhoods don't. Tree canopy specifically. And so what we're trying to do now is understand how this neighborhood, for example, in one part of a city differs from this neighborhood in the same city. So what we're seeing are ways in which we juxtapose these two neighborhoods to essentially see one neighborhood having a lot more of some things like tree canopy and another neighborhood having a lot less of some things like tree canopy. And so if we take that a little bit further, we can start thinking about why this is happening. And I have three provocations for you to consider as I get into this description of why this might be happening even today. The first is historic planning policies are exacerbating local effects of climate change. That we've known for some time, and I hope that isn't coming as too much of a big surprise since Kate has already set the stage really well on that one. Second, though, I want to provoke you a little bit by putting the onus on local urban forestry, local planning, local environmental services, local public works departments by saying we are seeing evidence that not enough is happening in terms of centering historically underserved areas with greening efforts. And so that is something I'm going to show you some data about in a minute. And third, I want to push you further in saying that these historically underserved areas are increasingly what I've been calling growth permissive, meaning that they are the place where if somebody says, I don't want this in my backyard, these historically redlined areas are where those lesser desirable land uses end up going. So think about the big box stores, think about the freeways, think about the industrial plants. The things that are ending up in these historically redlined neighborhoods it's even happening today, and it has a potential for squeezing out space for potential planting of tree canopy. So this is a pernicious process that I really want to underscore in terms of trying to present some experiences of everyday life in these neighborhoods. So again, we're trying to bring this down to the ground of what people experience as they're walking to work, as they're rolling to work, as they're commuting in any way in a tree-lined neighborhood versus a very sun-exposed neighborhood. And from last month's webinar on RX for cities, RX for heat and cities, you learn from Edith de Guzman and Dave Eisenman and others that this is something that is consistently reflected in even medical and health impacts that we're seeing for communities living in these under-canopied neighborhoods and often very hot neighborhoods. So what this really gets us thinking about then is this lived experience. And the two questions I want to ask in this are, how has tree canopy changed over time in these neighborhoods, meaning the redline neighborhoods, the non-redline, and their non-redline counterparts? And I want to present two sides of this picture. One is how have we been greening over time in these neighborhoods? And second, I want to get at this idea of how effective has greening been, or could greening be in these different neighborhoods? And while we always talk about throwing trees at things to cool things down, we're finding some early evidence. We're in the process of publishing some of this. This is just hot off the press, so to speak, or hot off the computer analysis, to essentially show that some neighborhoods and some cities actually have very differing historical patterns of greening, and some cities have very different ways in which greening could actually reduce temperatures in their area. So let me get into this with an example that starts at the national level. Kate already did justice to this, where you see from A, B, C, and D, these red line to non-red line counterpart neighborhoods, where we see in the upper right-hand corner, we see surface temperatures hotter in the red line neighborhoods versus the non-red line. That's at this point published. It's ready to go. There's an ArcGIS link here for you to go to. I think that's probably too many characters for you to copy, so when this gets posted, you can copy and paste that link and actually look at all the cities, 108 of them that we looked at in this paper, to see how tree canopy is doing, where the red-lined communities are, what the income is. And so we created an interactive web map for you to be able to dig a little deeper. Needless to say, more canopy in A graded neighborhoods, a lot less canopy in D, and that goes simultaneously with the impervious surfaces as well. Greater amount of asphalt, lots of highway projects, big box stores, industrial facilities, and lack of parks and green space. These are not necessarily new, though we've been able to systematically illustrate this across the country, and that this is a pattern that we're seeing, pretty significant one at that, for us to really begin to work with. And we've ranked these cities according to the difference between the red-lined areas and their the green-lined areas. So essentially, what is the temperature difference that we're seeing from a land surface temperature point of view? And the city I happen to find myself in now and these days is Portland, Oregon, which totally surprised me when I saw it at the top of the list as number one, of a temperature difference of almost 13 degrees Fahrenheit between the red line neighborhoods and the non-red line counterparts. Denver, Minneapolis, Columbus, etc., all 108. And so what we did was we took these cities, and to ask this question of how have these cities changed over time in terms of temperature, and the second piece is how could greening efforts in these cities affect land surface temperatures, the measures that we used. And so we used two data sets for this part. We used, one was the land surface temperature, relatively easily available, and the normalized differential vegetation index, NDVI, which many of you must, if you're in urban forestry, this is, or forestry in general, this is a measure that's often used to understand the photosynthetic activity as measured by satellites. And we can see that if we bring these two things together, we can start looking at individual cities in terms of what are the differences between these red-lined areas and these non-red-lined counterparts. And so the ranking really is about how much hotter are the cities, in relation to each other, and we rank them in their difference between the red line and non-red line counterparts. And so when we look at individual cities, we're starting to see that each city has a unique story in and of itself. While these national studies are helpful to show the systematic pattern, these individual cities are really interesting. So bear with me. I have a set of graphs to explain to you here. And on the left side, this is the city of Portland, Oregon, which we looked at. Now, looking at from the left side, this is a range. So if you just follow me, bear with me for a second. So the top graph, or the blue, is the red-lined A area. So those are the areas that were considered, quote, best from the Homeowners Loan Corporation for investment throughout this period. And then going all the way down, we have A, B, C, and D. D are the areas that are the red-lined areas. And on the left axis, we see a measure of photosynthetic activity, or the NDVI, on the vertical axis. On the horizontal of the left graph, we see the year, and that goes from 1984, 1994, 2004, and 2014, the most recent data that we could get, at least for looking at patterns for NDVI. And we can see for Portland, for example, over time, there hasn't been much investment or much greening effort put into into any of the neighborhoods, frankly, at least from the NDVI measures. And then from 2004 to 2014, we see an uptick across the board, all the neighborhoods. And that's on the left side. And then on the right, the things I want to bring your attention to is on the vertical axis is land surface temperature in 2014, and then land surface temperature, I'm sorry, and then NDVI on the horizontal axis for 2014 as well. Two things to note here. We distinguish these by the red line versus the non-red line neighborhoods. And so the red line, if you look at, and the 95% confidence interval bands that are surrounding those lines essentially show us slopes, and they also show us essentially what the relationship is between greening and land surface temperature across these neighborhoods. And if you notice for this one, the blue line is much steeper than the red line. And so what that suggests to us, and this is again early evidence of this work, and we're working through some of the intricacies of this, and I'd really welcome your feedback on this. But really what we're talking about is the blue line. When you're looking to add more vegetation in this, we're seeing a steeper decline in the land surface temperature in those neighborhoods, as opposed to the red line has a little bit of a flatter curve. That coefficient that we look at is a little bit flatter, so that could tell us a couple of things. That could tell us, yes, the relationship is not as strong, or it could tell us that the putting in greening into this neighborhood may not reduce the temperatures as quickly as other neighborhoods. And that may be because of other research we're doing, which I don't have time to present here, in the Portland metropolitan region and into the Pacific Northwest, where we're seeing that trees are actually, where these historically redline areas have lots of asphalt, lots of industries, and when you put trees in those very hot places, they get scorched. And we see limb failure, entire trees failing in terms of their increased vulnerability to heat and potentially other stressors that they're encountering. And so just throwing trees at these very hot places may not be the immediate solution unless we're really talking about a long-term maintenance plan for the vegetation as well. So just dropping a tree in, calling it good, is probably not going to be sufficient for adequately addressing some of these impacts. So I'm going to go through, similar to this, I'm going to go through a handful of other cities where we're digging in a bit further. We kind of we stratified our cities from those that were at the top of our ranking to the middle of our ranking to the bottom of our ranking to see how this played out across the country. And so Minneapolis was another one where we looked at, it looked like a leveling out of greening at least. If you look at the left graph in terms of time, how much greening has happened, again, on the vertical axis, and over time in the horizontal axis, we see that there are differences. Redline neighborhoods continuously start much lower and have a lot more to do if we're talking about equity in terms of a canopy distribution in cities. There's a lot more to do in terms of being able to make up for this. I will just note that the note that the other graph here has a much wider band, which may suggest that it's not quite as high in terms of confidence for the relationship between land surface temperature and greening present in 2014. And so part of where we're going with this is trying to see how much work do we have as a forestry community to make up for in terms of getting an equitable distribution of canopy in cities. That's really where the broader picture of where we're trying to go with some of this work. While there are a lot of million tree campaigns, 90,000 tree campaigns, etc., these suggest that we need a heightened level of precision and effort that goes into really making up for these massive historic inequities that have been placed on our city. So I'm going to go through a few more of these. Philadelphia, very interesting, kind of a, doesn't matter whether you're in a red line in some ways or in a non-red line, the slopes are relatively even on this. It's got minimal change over time. Springfield, Illinois, there's been a recent uptick that's happened, though it has been a constant increase, and then it looks like there is a pretty consistent relationship between land surface temperature and the amount of greening as well. And then a couple others. Asheville was one of the middle ones, and we're seeing that, you know, the red line, in this case, the red line on the left graph is almost identical to one of the still desirable neighborhoods considered the B Holt grade. And then we also have Tampa, Florida, where there's been a rapid decline that happened between 1984 and 2004, and then this rapid uptick that's happened in that last decade between 2004 and 2014. And finally, Seattle, Washington, which has had a constant increase across all grades. Again, this interesting relationship between greening that's happened in redline neighborhoods versus the non-redline counterpart of the one of still desirable neighborhood of B, where we're seeing a constant increase, and redline neighborhoods really in many ways catching up to the non-redline counterparts in some ways. So part of what I would hope that you would take away from this set of data that I kind of a very clunky presentation in terms of these graphs, admittedly, is that each city has a unique story with this. And the work that Kate and Groundwork are doing with some of these localizing redlining effects is really essential for us to understand why some communities are more likely to have effective applications of greening in these historically underserved neighborhoods than other cities. And so we really have to unpack some of what's on the landscape, how is it doing over time, what are the relationships between land surface temperature and NDVI. And so with that, I just want to close with a set of slides that just essentially take us from, yes, land surface temperature is one thing, though we really also want to know what that lived experience of people how those lived experience of people can affect their health and well-being. And land surface temperature, with it being freely available, relatively easy to mix with other data sets, it doesn't quite get us at the lived experience. And there are many strengths to using these kind of satellite-based descriptions of heat. They're freely available, they're extensive literature, etc. There's also several weaknesses. It's a very coarse pixel size, so we're looking at massive, often 30-meter by 30-meter pixels from space. We're looking at rooftops and roads, not really the ambient temperature or the air temperature that we feel or our buildings experience in terms of the thermal gain of solar radiation. And so part of what we are also have embarked on, and some of you may know this work because we've been very fortunate to be partnering with NOAA and their Climate Program Office and the National Institute, the NIHIS, National Integrated Heat Health Information System, have been incredible partners in trying to advance this work. We've also got some funding from U.S. Forest Service for doing this work across 5 cities in the western U.S. And so we've got some great partners to develop this heat watch engagement model where we're essentially moving forward and engaging communities and describing local climate-induced hazards like heat, developing analytical tools, and then supporting capacity building at the local level. So what we do with this program, and I'll just give you just a real brief summary of it if you're not familiar with it. We engage locally. We worked with Groundwork RVA, which was Richmond, back in 2017. 2017, we worked with Groundwork in Yonkers last year in 2019, and that work continues in both Richmond. And now to kind of reconnect with Groundwork through this presentation has been really coming around full circle, where we've engaged with local nonprofits, local universities, local cities, municipal bureaus like sustainability or planning or forestry. And then we provide training materials to community groups to essentially embark upon a data collection campaign where communities go out and collect hundreds of thousands of measurements of temperature and humidity, engaging a vast network of volunteers. We just finished one in Houston, in Harris County, where we had upwards of 80 plus volunteers engaged with very sensitive temperature and humidity measurement systems and going out and collecting these, and we're essentially developing a set of maps that show this distribution of temperature across a region. And that's at a very high resolution, often 1 or 10 meter resolution, which allows us then to start talking about what could you do in these places. And not surprisingly, like in Richmond, we found places that were historically redlined were far hotter not only from land surface temperature, we also found very consistent patterns in air temperature in those areas as well. And that allows us to kind of look at which areas were better identified with air temperature in terms of these campaigns. Here's a slide that I've picked up from the NIHIS website. If you haven't been to the NIHIS website, I encourage you to go take a look at these campaigns. We have this essentially 7-step process that we take communities through. Here's a distribution of all the cities that we have been engaging in this year. The ones that are in blue, ones that are in black are ones that we've done in previous years. And so it's been a really robust campaign. You'll see some big gaps here, like in the southeast, North Carolina, South Carolina, Georgia area, big open areas in the Midwest, inner Rocky Mountain West. We don't have any communities that we've worked with there. So Denver, calling you out. I'm calling out Salt Lake City. I'm going to call out Charlotte, North Carolina. I'm going to call out Atlanta, Georgia, etc. So a lot of these cities through this area, we'd love to work with you in the coming years to move forward on this campaign. Here's a recent image of what we did in terms of getting the community out. They put a little instrument on their passenger side of their car, or we have bicycle mounts where people can go out and collect these measurements. And to date, for this year, we've had over 600 volunteers engaged in 1 month on this campaign. This is a little news clip from the Rhode Island effort that's really focusing on equity and health impacts in these equity zones that were developed, and so it really segues well into their existing systems. And so finally, here's some outputs. We show where people have gone, what the maps look like, and then we can link those to redlined areas and otherwise, and start really thinking about what are the ways we center historically underserved communities and catalyze activity for moving towards social and environmental and climate justice efforts that are already likely underway in some of these areas. Work with us next year. It would be grateful to learn more about what it is that you're interested in doing. If you connect with us after this campaign season, we only have a set number of slots every year, so in terms of capacity, so we start in January and we really take it through the whole year. So we have a wonderful cohort of 13 cities through the NIHIS and 15 in total this year that we're working with, and we've just been learning a huge amount, and there's been so much emphasis on equity and perhaps with the Black Lives Matter movement and all of the movement that's happening in transformation right now. We've seen a real uptick in the kind of centering of these questions of justice and health and well-being in with the communities we're working with. So I'll end it with that and just ask you to think about your neighborhoods. Which ones are locked in? Which ones had freeways put right through them back in the 50s? Which ones are really getting all the lesser desirable land uses cited in them? And how do we actually start thinking about this more explicitly from experience of place perspective? And so I'm going to leave it at that. There's some contact information. My contact information's there. There's some information on Kappa Strategies, which is the consultancy that I use to be able to enable some of these campaigns to run forward, and I'll leave it at that. Thank you.